Wi-Fi Tech Lab channel. We're still on the same topic. This is dynamic routing protocol topic, and this time around we are actually gonna be utilizing if-ng to try and configure this topology of the routing information protocol version 2. If you haven't watched our recent or our previous video, you can just go back. It also focuses or based on the routing information protocol. Okay, the difference between is just that in today's lab we will be bringing the internet so that you will see the PC that is located on this network segment to actually send the packet across and touches the internet. Okay, so what do we have here on this lab? As you can see, everything is just colorful. So on our left hand side we have our local area network, and then we have this network ID. So this is going to be our local area network, and then this is the network ID that we'll be using on that local area network. In this case we have 192.168.10.0/27. What does that simple mean? The /27, it simply means that the subnet mask that will be used on this network ID is going to be 255.255.255.224. Okay, same thing applies on this local area network that is on this router here, which is router 6. If you check their numbers, there is router 1 over there, there is router 2 over there, we have router 3 over there. I'm just gonna change that naming. We have router 4 over there, we have router 5, we have router 6, and then lastly we have router 7. Okay, so if we move to router 6, you can see that we have this local area network. In this case, ever since we won't be using the computer just like that, so I will just create a loopback interface that we will ping from. So we are expecting to ping from this source, from this local area network on that router here. Okay, because as you see these routers, it might happen that they are actually too distant from each other. Maybe the other one is actually located in far away. So let's move on to this router over here, which is router 5. If you pay attention on this router, we have the network ID of 192.168.10.64/27. It also have the same subnet mask of 255.255.255.224. Okay, and also on this network ID over here, which is using 192.168.10.96/27, with also under the same subnet or under the same subnet mask, which is 255.255.255.224. Okay, so these we're going to be configuring two loopback interfaces here. As you can see, this is loopback interface 0, and then this is loopback interface 1. Okay, on that router, which is router 4, we have 192.168.10.128/27. This is the network ID. It is not assignable on the device. We can only, on the interface, you can assign on the device, but you can't assign on an interface. So, which means the first usable IP address of that is actually .129. In this case, we're gonna use 129 as our default gateway, and also on this one we're gonna use 97 as our default gateway on that interface, which is a loopback 1, and loopback 0 here on that router 5. We're gonna use 65 as our first usable IP address on that subnet. Right, now let's just check our routers that we have. Remember, we said we have 1, 2, 3, 4, 5, 6, 7. So we have a maximum of 7 routers in here. Okay, and we actually utilized the network IDs, which only allows 2 usable IP address on each subnet. So which means we are expecting to see 10.10.10.1 as the first usable IP address between R7 and R1, and the last usable IP address to be 10.10.10.2. That is the last usable IP address on this network ID. So if we go to router 1 and router 2, same thing applies. We have 20.20.20.1 as the first usable IP address, and we have 20.20.20.2 as the last usable IP address. That is the IP address that will be assigning on fast 0/0 on router 2. Okay, now same thing applies on router 2, between router 2 and this router 3 over there. It's just same thing applies. Again, on between router 3 and router 4 and router 5, router 5, router 6, router 7, and router 6. Same thing applies. And remember what I said, these routers, they might be located in different and far distance from each other. So as you can see, we actually have used this coloring to actually try to distinguish between these two parts. As you can see, we have this dynamic routing protocol, which is RIP version 2. It actually utilizes the metric that determines the number of hops on the path. In that case, we have only two paths to get to the internet. We have, let's say, suppose we have the packet that come from this host over there on this network ID 192.168.10.0 network ID. And remember, /27, it simple means it only allows 30 usable IP addresses on its subnet. Okay, so per subnet, it's actually allowing 30 usable IP addresses. Okay, so suppose we have a packet that is leaving, or that is actually coming from this network ID, and it goes to this router, which is router 7, where there will be a routing table that exists on this. Remember, we've talked about the control plane and the data plane. So there will be a routing table which is located on R7 that will be determining where the packet will be forwarded. The metric will be will be already calculated to check which path is actually having less number of hops, or which path is actually easy in terms of hops to get to where we're trying to forward the packet to. Okay, to the destination specifically. So on that router from here, there are two paths. There is this path, and then there is that path. Now, what is a hop? A hop, or in this case, the hop from here, it's that interface over there. This is the first hop. This is the second hop. This is the third hop from that router. Okay, from that router, the first hop is that one, and then the second hop is that one. The third hop is that router 3 on gigabit 0/0. Okay, same thing applies on this side. We have the first hop over here, and then we have the second hop on this one, which is router 5, and then we have the third hop on router 4, and then on router 3 we have so it's 1, 2, 3, 4. We have the fourth hop. Okay, remember, again, let me remind you, dynamic routing protocol, it actually utilizes the hop counts, that what determine where the packet should be forwarded based on the number of hops. The lesser the number of hops between two paths or between multi-paths, that path that have less number of hops, this is the path that would be preferred to route the packet towards the destination. Alright, so we're gonna run a trace route once that PC is actually connected to the internet. Alright, so let's just dive in and see what is the configuration that is already done on these routers. I will just tell you because we didn't want to actually spend a lot of time doing the same thing over and over again to assign all of these IP addresses. So I've just cut the video short, so I just assign all of those IP addresses. However, we can utilize the troubleshooting step to actually show what are the configuration exist on that particular device. First thing first, I'm just going to try and access that router and type in the command enable. From this privilege config mode, we can be able to see everything that is configured on that router specifically. For now, what I'm willing to know, I'm willing to see what are the IP addresses that are assigned on all of these interfaces. Okay, specifically for this router here, because we are currently here, we can see that there are 3 interfaces. These are the directly connected interfaces of this router. Fast 2/0, which is the default gateway of the local area network, and then we have that fast 0/0, which is the point-to-point communication between R7 and R1. It's a unicast traffic. So, and then we have the same thing on fast 0/1 towards fast 0/1 on R6. Okay, so all I have to do is to type the command do show, let me just write it in full, do show IP interface brief. Okay, sorry, I don't need to specify do show. I got used to run this command on a global config mode. So you just type in show IP interface brief, and then it's gonna show you all of the information based on the interface state. It's either up, down, or is there any IP address that is assigned to it. In this case, we are trying to look for these 3 interfaces. So as you can see, we have that 10.10.10.1 as the first usable IP address on that network ID, which is 10.10.10.0. So we have actually assigned this IP address on fast Ethernet 0/0. This is 100 meg, 10 to 100 meg. So let's come to that interface over there, which is fast 0/1. We have this last usable IP address on its network range, which is 70.70.70.2. This is the interface that is located on R7 between R6 and R7. Okay, it also uses /30. So let's check now on fast 2/0. I'm just gonna try to go down. Okay, as you can see, this is the IP address that is configured on that interface over there. Of course, if you don't know how to configure the interface or the IP address on the interface, you can just go back to our previous videos and see how to actually configure the IP addresses. Even though we've been dealing much more based on class C IP address, we still gonna actually talk more or dive deeper to binary and subnetting. Okay, and we will touch upon all of those class A, class B, class C, multicast, and classless. Okay, so IP addresses. Now let's go to this router over there and also confirm if the configurations are supposed to be as we are expecting. I'm just going to try to type the command enable. I'm not going to navigate to global config mode until we actually try to configure something. Okay, so all I want to do, I want to show IP interface brief. Okay, if you don't want to see the brief of this, if you can get the detailed information when you type the command show IP interface. This is going to list all of the interface with the details. As you can see, we have that interface. It's going to tell us that okay, this is okay. It's going to tell us that we have internet, which is 10.10.10.2/30. in which we actually need to change. As you can see, we have a we have a broadcasting IP address, and then let's go down there, which is MTU. This is the default MTU size. So if you go down, you will see much more information of what is actually going on here. Okay, this is just the broadcasting IP address, and then this tells us that this class belongs to /30. All right, so this is the multicast. Okay, let's go down. All right, so what I'm trying to do is I'm trying to show you the IP addresses that are configured on that router specifically. We are expecting to see only 2 IP addresses. Do show IP interface brief. As you can see, we have those. This is the last IP. This is the last usable IP address on this network ID of 10.10.10.0, and this is the first usable IP address between R1 and R2. Okay, this is the interface that we're talking about. As you can see, we have fast 0/1. This is the interface on that router over there. So I'm just going to minimize this and move along to router 3. Sorry about that noise. And then I'll run the same command, show IP interface brief. Same thing applies because there are only 2 directly connected interfaces on that router. So we have that last usable IP address of 20.20.20.2, and here on that interface we have 30.30.30.1 is our first usable IP address on router 2. Okay, now let's move on to this router over here, which is router 3. On this router, we have another interface, which is the dead interface, which is directly connected to the WAN also, or which is facing the internet. Okay, this is the interface that is facing the internet. Let's come in here and type in the command do show, not do show, it's actually show IP interface brief. All right, what do we see currently here? We can see that these are the IP addresses that we are actually focusing on, which is this one over there, and we have that one over there. The last usable IP address on that interface of this router 3 gig 0/0 is actually 30.30.30.2. That is the last usable IP address. What is the next IP address that can be used? None, because the next IP address of .3, that is going to be the broadcasting IP address. Okay, now what about this interface over there, gigabit 0/1? This one we have actually assigned the IP address of 40.40.40.1 as the first usable IP address between router 3 and router 4. Right, now let's go down and see gigabit 0/2. Gigabit 0/2 currently have no IP address. We can either configure this in both ways. So we can choose to assign the static IP address as long as we know what is the subnet mask that is used between that interface and the ISP side, or between the router that is facing the internet. So basically, if we know what is the public IP address or what is the IP address that is used on the other side, we can actually configure the static IP address. All right. So another way we can use the dynamic, the DHCP, to actually get the IP address list by the other router on the other side. How do we do that? The first thing we need to do is to navigate to global config mode, and then we can actually type in the command interface to select the interface that we actually willing to perform some configuration based on. Now we can be able to do some configuration, IP add DHCP, and then I need to say no shut. Let's give it some time. So the other side, because there is a DHCP running on the other side, I'm actually using something called a Citrix 192.168.1.1. Okay, I'm just gonna remove that. I'm trying to show you exactly that because I'm using a Citrix device. It has some sort of a DHCP server to list the IP addresses. So that symbol means that on the other side, because there is a router that is enabled with a DHCP, that means if I type in that command on that interface, I'll be able to get list with the IP address, okay, on this interface. If I click on here, you'll be able to see that the IP address that I got now, let's give it some time. The IP address that I got is actually on the same subnet mask or on the same network segment of that. Okay, 192.168.101.0 network ID. All right, so what does that mean? It means if I can try to do a ping, to 192.168.101.1, which is the default gateway of the other router on the other side, or of the other device that is actually dishing out the IP address, I can be able to ping it, and I can also ping any device between that network ID. All right, so I can even ping that 192.168, which you see in here, which I'm using to access this event G. I can even ping it from that router now. From this router, as you can see, the success rate is 80%, 4/5. The first ICMP was dropped, and now this time around, all of this is sent and received. I can be able to ping that. All right. Now, let's do this. Let's try to ping to the internet from that router. Let's see what's going to happen. We should be able to ping from that router to the internet. As you can see, we've been trying to ping the DNS server for Google. Now, if we can also try to ping, the Cloudflare, we should be able to send and receive the packet or the ICMP. Now let's try to ping maybe Facebook. Do ping facebook.com. As you can see, we can also ping facebook.com from that router here. Now there's another command which is actually not utilized on CCNA level. However, I'm gonna show you now. You can actually ping from the same router, but you can ping from the directly connected interfaces on that router. In this case, I can only ping from here. If I run the ping, do ping 8.8.8.8.8 and then type the command source. This is actually gonna allow me to ping from a specific interface. I want to ping from this side on that router. From the last router, I want to be able to ping on that interface. All right. What if we ping from that interface? Let's see. Well, the packet is going to be dropped. All right. That is what we are expecting at the moment, because we still have to actually configure the routing information protocol on all of those routers. All right. The packet will be actually dropped even on the other interface too, which is gigabit 0/1. Okay, I'm on the same router, but I'm trying to ping from different interfaces. In this case, we are trying to see the packet that is coming from this side, if it can be able to reach to the internet or to that Google DNS. Unfortunately, it can't. Let's run the ping one more time so that you will see on the router itself we can be able to ping to the internet. As you can see, we're getting the successful rate is 100%. Okay, now let's do the magic on that PC over there. Let's see how far this PC can be able to ping. Remember, this is the operating system Windows 7. On this interface or on this network interface card, we actually let me just come in here on the CMD, type the command ipconfig/all. I'm trying to show you exactly which IP address that was statically assigned on that Windows 7. We have that 192.168.10.3 IP address, and then we have this subnet mask of 255.255.255.224, because this is /27 network, and we have the default gateway of 192.168. We need to change this 168.10.1. We need to modify this. I'm just gonna try and modify that over there on I'm just gonna go and type ncpa.cpl so that you'll be able to see also how to navigate to network adapter setting on any Windows operating system. So if I come in here, I can go to IPv4, because this is the IPv4 that we're actually utilizing here on this lab. It's not IPv6, so I'll have to double click in here and change this one to 168. This is actually another way of troubleshooting when you see that there is some things that is not tying up on when you're running those commands. All right, so I'm just going to click OK for now. Okay, now if I go back on that CMD and run the command ipconfig, I should be able to see that the default gateway is 192.168.10.1. all right, so from here I can be able to ping 192.168.10.1 from that PC. all right, as you can see, we have the time to live, we have the response, we have sent the ICMP echo. Now we echo request, and then we got the reply. We sent 4 packets, we received 4, and then we lose nothing. all right, what if now I'm trying to ping on 10.10.10.2? I'm just going to try to ping on that next hop over there. Let's see if we can be able to ping to there. It's 10.10.10.2. I'm not going to be able to ping. Okay, this simply means that the router itself have some old configuration of the RIP. I'm just going to try to go and remove it so that you'll be able to see that actually I'm not going to be able to ping on that interface without the router RIP. So let me just remove this. No router RIP. Okay, now let's go back and try to ping from that PC again and see if we're gonna be able to reach in there. We are expecting to not be able to reach on that destination because there is no routing protocol that actually exists with the routing entry that tells where the packet should go. all right, now let's go back and actually do the configuration on all of those routers to allow the RIP to do its functionality on this network infrastructure. all right, I'm gonna start with R7 and actually configure this routing on this R7. Okay, first thing first, I've enabled the router itself and navigate to config terminal. From here, the command that I need to type is router RIP. I have to specify the version, which is version 2. Version 2 supports the classless routing and subnetting, okay, which is why we use it. So it's version 2, and then we need to advertise all of the network IDs on each and every directly connected interface on router 7. In that case, let's start with the local area network here, which is 192.168.10. I'll just type in the command network 192.168.10.0, and then I'll move on to the next interface, which is 10.10.10.0. Then I will move on to the other interface, which is 70.70.70.0. Now all I have to do is to type in the command in no auto summary. Okay, I'm just gonna save this. Do right. Okay, I'll have to repeat the same command or the same format of this command in all of those routers. This is the basic way of configuring the router information protocol. Of course, in advanced, we can actually try to configure the authentication on this router information protocol. But for now, we're not going to configure any advanced configuration on this routing information protocol. Let's move on to this router over there. On that router itself, let's configure the router RIP same way. We need to specify the version that we are using, which is version 2, because if we don't specify the version, the routing information protocol or the RIP will only assume or use version 1, okay, which doesn't actually work accordingly with the classless or the subnetting. All right, so let's advertise all of those directly connected interfaces with their network IDs. In this case, I'm just going to use 10.10.10.0. I'll do the same thing on the other interface, which is 20.20.20.0. Where am I? I'm on this router over there, which is router 1. As you can see, the host name says it. This is router 1. So we have 10.10.10.0 and 20.20.20.0. I'll have to type in the command no auto summary, and then I'm just gonna try and save this. Let's move on to that router 2 over there and type in the same command config terminal. This is gonna take long. I'm just gonna move on to the other router, which is this one. I'll come back to router 2. Okay, while we're waiting for this one also, let me go to router 6 and type the same command config terminal. On router 6 over there, which is this one, we can see there are two directly connected interface, which is fast 0/0 and fast 0/1, and they're utilizing these network IDs, which is 70 and 60. So I'm just going to advertise those two. First thing first, let me configure a router RIP and specify the version, which is 2, and then I can say this is actually 70.70.70.0, and the second one is 60.60.60.0. No auto summary. Do right. Okay, just gonna minimize this. We have done the RIP configuration on router 6. Let's go to router 5 and do the same thing. Enable config terminal router RIP version 2. Let's advertise some network IDs. In that case, I'm going to advertise 60.60.0 and 50.50.50.0. No auto summary. Do right. Now let's move on to router 4. Remember, we still have the router 2 and router 3 that we still need to configure because we skipped them. Now let's configure router 4. Router RIP version 2, network 50.50.50.50, sorry, it's .0, and the second one is actually 40.40.40.0. This is the router that I'm currently configuring now. We have allowed this interface and that network ID on that interface. All right, we need to type in the command no auto summary and save this so that we don't lose the configuration. Now let me go back now to that router. It's actually this one over here. So this is router 3. As you can see, we need to type that command router RIP version 2 default. Because this is the router that is facing that internet, let's just type in this command route default information originate network. Let's advertise 30.30.30.0 network 40.40.40.0. Okay, now let's even advertise this one over here. Do right. No auto summary. Do right. Okay, our configuration is done on that router. Now let's move to router 2. Okay, it's taking long again on router 2. Let's just wait for it a bit. This time I'm just gonna wait for it. Once it's done, and then I'll be able to carry on and configure the routing information protocol. Okay, so remember, this is the traditional way of routing packet. Nowadays they are SD-WAN, software defined WAN technologies that are utilized to actually send or allow the packet to travel most effectively. Okay, now let's type in the command config terminal. And remember what we said about the RIP. The RIP have a limited number of hop counts that it can be used on its network topology or on its network infrastructure. So it can only allow 15 hops, so which means it's not scalable in that extent that if you have actually more than 15 hops, which means you won't be able to further use or utilize this routing information or this dynamic routing protocol, which is RIP. Now let's type in the command router RIP on R2. Let's specify the version, which is version 2. Let's specify the network IDs that we are willing to advertise in here, which is 20.20.20.0. As you can see, we're going to advertise 30 and 20. So the last one that I'm willing to advertise is 30.30.30.0. No auto summary. Do right. We have actually successfully configured our dynamic routing protocol, in this case the RIP. Right, now let's verify the routing table. Let's start from this one over there, which is R7. if I can come in here and type the command do show IP route, this will always show you the routing table on any device. All right, this is the table which actually shows us how to get from this network towards which network using which protocol. All right, in this case we have those C. These simply means these are directly connected interfaces, and then we have that R symbol which symbolizes that this is the RIP protocol, or this dynamic routing protocol, that is actually detected as the entry on the routing table. All right, it tells us the administrative distance, which is 120. Okay, so remember there are three criteria that we actually look when we try to see, not just in RIP but entirely in a routing table. There are three criteria that we actually look at mostly when we're trying to match or see which path can be taken from this particular source to that maybe network ID or towards that certain destination. Okay, we look for the highest prefix match, we look for the highest or the longest prefix match, and then we look for the administrative distance, and then we look for the matrix or for the cost. All right, now let's go to this route over there and see if we have all of those dynamic routing protocols, specifically the RIP. I'm just gonna try and come back on this one. I'm just gonna do two of them. Show IP route. Okay, as you can see, we still have the same result. We have all of those entry for the RIP, which tells us that to go there we must go via this certain hop or something like that, or to go via that certain interface, and it actually tells even the time that it takes, all of those. Now let's come back to our testing. Now this is the time for doing the test on this device specifically, because this is the PC that we are actually trying to utilize to get to the internet. All right, so as you can see, this still have no internet. As you can see, we have no internet access at the moment. It only knows how to get from this router towards that router and towards that router, but it doesn't know how to get to the internet, in which it is something that we still have to configure. Now let's run our test and see where it can go and where it cannot go. All right, let's break it down from this side on this path. Let's break down path 1. As you can see, we have path 1 and path 2. We're going to try to ping the 10.10.10.2. We're going to try to ping the 20.20.20.2, and we're going to try to ping the 30.30.30.2. We expect to see the successful ICMP echo or replies. Let's do this now. Let's try to ping 10.10.10.2. All right, as you can see, we can be able to ping towards that side. Now let's ping 30. I'm just gonna try to, so let's start with 20.20.20.20.2. I can be able to ping. The only reason that allows us to ping on that router is because of the dynamic routing protocol, which is RIP, that we just configured on these routers. And you will see also, as soon as I remove it in all of those routers, you will see the difference, because I'm just going to do that in the end. I will go back and reverse all of this configuration that we have done to on all of these routers, but I will just choose few routers so that you will see that when the packet is actually lost between that certain hop or between our two routers, it will not be able to use that path. Instead, it's gonna utilize another path to get to the destination. Now let's see if we actually try to ping to 30 this time around. Let's ping to 30.30.30.2. As you can see, I can actually be able to ping to 30.30.2. okay, what if I'm trying to ping? So this path is now valid. Now let's see if I can ping towards 192.168.101.1. well, decline. I cannot ping towards that gateway, which is the Citrix. This is the Citrix, right? So I cannot be able to ping the interface from here. Okay, now let's see on this path over here what we can ping and what we cannot. We're expecting to be able to ping 70.70.70.2, 60.60.60.2, 50.50.50.2, and that's 40.40.40.2. Let's ping all of those. Let's start by 70.70.70.2. As you can see, we can be able to successfully ping 70.70.70.2. This means that if I have some SSH that is configured on this router, I can be able to access it on that PC over there. And if I have SSH, or if I try to configure or run some configuration on this router, but I'm on that network, I can be able to dial in via SSH and be able to configure this router over there. Okay, now let's ping 60.60.60.60.2. Same thing applies, and the reason why we can still ping is because of the RIP, the routing information protocol, that we've been configuring manually on these devices. Okay, so now let's ping 50.50.50.2, 50.50.50.2. Same thing applies. We can be able to ping on that router over there. This is the router. This is the interface that we are pinging. Is located on this router, right? Now let's go and ping that 40.40.40.2, 40.40.40.2. Even that router 2, this router over there, we can be able to ping from. Now let's try to go back to pinging the internet. Of course, we won't be able to ping anything to the internet, but I'm just gonna run the continuous ping this time around so that you will see the changes as we play around with that router which is facing the internet, which is router 3. Sooner or later now, we are expecting to see the internet on this device, which is located on this subnet mask, which is 192.168.10/27. Alright, so let's come to the router, which is router 3. Just gonna do this. This is the router I'm talking about, and then I'm just gonna bring this one back so that you will be able to see. Again, I'm gonna run the same command, and this command is actually do ping 8.8.8.8.8. As you can see, we can still ping to the internet, but suppose we're willing to ping from other sources too. Let me just do this. Do ping from this source, which is gigabit 0/0. I'm pinging from this interface over there. Let's see what's gonna happen. I won't be able to go to the internet. Alright, now let's do a ping again from this internet also, sorry, from this interface also, and see if we can be able to go to the internet. Of course, we cannot be able to go to the internet. All right. But at least on this device, it doesn't tell us that the destination is unreachable. It just tells us that the request is actually timed out. All we have to do now, we have to configure the access control, or the access list, sorry. And then from there, we can further configure something called the network address translation. So we just need to type in the command access list. This is the standard access list. We have the set of range that we are using according to the access list. 1 to 99 is the standard, and 100 to 199 is actually the extended. Okay, now let's come in here. Let's type the command access list and then just use any number in between 1 and 99. I'm just gonna prefer 10. Okay, and then I'm just gonna say access list permit, because we are trying to permit or deny traffic. In this case, I'm just gonna try to permit anything from inside towards outside. I'm just gonna permit everything for now. Remember, I've said this, we're still gonna come to access list and see and test around which network ID is allowed to pass through towards that interface, or towards this destination. We still need to dive deeper on that, but for now I'm just going to utilize this because it is very necessary. So we're just trying to permit them. Remember, the access list matches, it uses match rule, so we can permit the traffic now from any network. Okay, now let me just type the command do route. As you can see now, as soon as we have permitted the traffic, the internet on that device started to work. Okay, as soon as we have permitted this, the internet just started to work. I'm just going to remove the access list so that you will see the difference. This is actually very useful in order for us to be able to access the internet. Okay, even though the speed is very poor, it's because all of those interfaces, they are 100 meg links. And okay, now let's come in here. I'm just gonna say no access list so that you will be able to see the changes. The packet will be dropped on that PC, which is Windows 7. Okay, no access list 10. Okay, let's do this. Do show run. I want to see the configuration that is done on that router to see if the access list is actually removed. Okay, while we're still waiting, let's go back and check that router over there. I mean that Windows 7 over there, and see if we can be able to actually get into the internet, because we might not be able to go to the internet. Actually, I'm just gonna do that right now. As you can see, the network icon has changed now because of that command. All right, just gonna try to maximize this so that you will be able to see. I have actually tried to open up the browser over here so that I'll be able to search anything from the internet and download the page. Okay, I'm just gonna try to test with Facebook this time around. Facebook. Okay, it's actually taking longer than expected. Let's just wait for it a bit. I'm trying to minimize this. As you can see, we cannot be able to actually ping to the internet. The reason why is because of that access list that we have removed. I'm just gonna configure that access list again one more time, because we removed it, so that we will test and see if we can access the internet. This time around, as soon as I update it, we should be able to access the internet. Alright, I'm just gonna do that right now. And refresh the page so that you will see the difference between the two. Okay, now let's type in the command access list permit anything, do right. Okay, I'm just gonna try and test, and I'm just gonna try and refresh the page so that we will be able to see what's gonna happen after or as soon as I actually allow that access list to okay. Now you see the difference. The page is getting downloaded from the internet as soon as we have put back that access list 10 permit anything from internal to external. Alright, so it's still trying to download, even though it's slow, but as you can see, it's trying to download something from the internet. As you can see, we have actually successfully downloaded the page from the internet. As you can see, we have that Facebook link or the applications. I'm gonna try to move this. Okay, we have this Mark Zuckerberg over there. We have actually configured this routing information protocol successfully. As you can see, we have that network, which is network 3 over there. We can search anything on the internet. Alright, even though it's very slow, but we can actually search anything on the internet, including Twitter itself. I'm just gonna try and click to Twitter. Okay, it's actually taking a little bit longer, but the point is that we can actually get to the internet from that PC. Alright, this is running Windows 7 and it's running using my resources that I have. So let's wait a bit. Let's just type in speed test. Speed test by Okla. As you can see, I can be able to even go and type that speed test. I'm not gonna go there and reveal my public IP, but that is actually how we can configure the routing information protocol. Now let's run some tests again and see what happened actually when we, let me just try to do this. I'm just gonna minimize this. So remember, when we're configuring the net, all we have to do is actually type the command ipnet inside, and then specify the source source 10 interface, ipnet source list 10 interface overload. So we are willing to select this interface, which is gigabit 0/2, and then we are willing to overload it. Okay, dynamic mapping is in use, you cannot change. Okay, so IPNet inside source list 10 and then overload. So this is how you can actually configure the IPNet inside source list, but we are coming to that also on how to configure the pad, on how to configure the IPNet as well. All right, you can go and select those interfaces as the IPNet outside and these two interfaces because they are internal to be IPNet inside, and then you can go and see the translation that is occurring on the router as the packet being overloaded towards that interface and going outside. Okay, so now it's time for us, without wasting time, it's time for us to actually troubleshoot and see what happened to this device over here. I'm just going to close this browser. I'm just going to leave this continuous ping for us to be able to see the packet drops to the internet. As soon as I break, I will have to be able to break two parts because, or maybe before I actually break something or anything, let's see which path is actually used to get to the internet. By typing the command trace root or trace it in Windows, I can actually trace root to the internet. This is gonna list the number of hops or the hop list with the IP addresses. This is gonna tell me the path exactly. As you can see, this is the default gateway of where this Windows 7 is located. This is its default gateway, so it uses that router over there, this path. As you can see, remember we have said that this slab have two parts, and the path that have less number of hops in this slab is actually this one, part 1. Why? Because we have that first hop from this router. I'm calculating the hop from this router. The first hop is there 1, second hop is there 2, the last hop is this one, which is 3. But when you come from this one over here, we have that router 7, 1, 2, 3, 4, which is why actually we utilize that path to get to the internet. Right, now let's try to drop this router over there by typing the command. I'm just gonna shut down one of the interfaces. I don't need to remove the RIP. I can just shut down any of the interfaces. In this case, if I select interface FA01, now the RIP will utilize the other path, which is path 2, to get to the internet. So I can just say shut down. That interface is actually down now, as you can see. If I type the command do show IP interface FA01, it's gonna tell me exactly that the interface is administratively down. The administrator just manually allowed this interface to be down. Okay, and the protocol is down. Now what happened on that Windows 7? As soon as we close the interface that it was using to access the internet, remember we have two parts in here, which means now it's gonna go to 70.70.70.2 because that is the other part that it can be used on the routing information protocol to get to the internet. Okay, as you can see, we have that first hop that we got. As you can see, it's now utilizing this path over here. I'm just gonna try and show you. I'm gonna minimize this. It now utilizes this path over here. As you can see on a trace route, it is listing all of these IP addresses that are under this path. Okay. Okay. So basically, as you can see now, the path that is used by the RIP is actually the second path on this side. Now let's see if we can be able to ping to the internet by typing the command ping 8.8.8.8, As you can see, this is the route now that is used by the routing information protocol to actually forward the packet or the traffic towards the internet. Why is that so? Because the interface that we shut down on the other path on this router, if we can try to kick it out, this path over here, which is the path 1, it can be reutilized again as a forwarding path towards the internet. As a result, that these have the less number of hops, as the routing information protocol uses the less number of hops to determine which part should be taken when there is two comparison between the parts. Okay, now let's just go to any of these routers. All I'm trying to do now, we're trying to test what if we were trying to ping from these loopback interfaces. Let's start by the loopback interface, which is located on this router, which is R6. I'm just going to try to access R6. Sorry about that sound. So if I enable this router and type the command config terminal, from R6 I can actually try to see if the interface loopback0 is actually have any IP address. Do show interface loopback0. Okay, as we can see, we have that IP address which is actually configured on the loopback interface. Now let's see if we have actually advertised, or let's just re-advertise it to that RIP by typing the command route to RIP, and we can actually specify this network of 192.168.10.32. Okay, exit. Now let's try to ping to do a ping to 8.8.8. so we're trying to ping to the internet from that router 6. Let's see if we're gonna be able to actually get something. As you can see, we can actually ping from that router. Okay, let's just wait. Let's give it some time. Let me see again if I can ping by its IP by typing the command do ping 8.8.8.8. Let's just utilize the IP addresses. So I'm just gonna try to ping towards the internet, but from a specific source of 192.168.10.32 network. Okay, but in this case I'm not gonna use the IP address or the network ID. I'm just gonna use the interface, which is loopback0. Okay, it's loopback0. This is L0. Okay, as you can see, we can actually ping from the loopback interface on this router 6. So we can ping from the loopback0 on that router 6. Okay, we can ping to the internet. Now let's go to this router over here, which is router 5. We're expecting to ping from this network ID and also from the network ID. As you can see, we have the loopback0 on this network ID, and then we have loopback1 on that network ID. Okay, let's just telnet to this or SSH to this device. Config terminal. Now remember what I did. I have to type in the command do show interface. Let's start by the loopback0. I want to see which IP address which is configured on that interface as its default gateway. As you can see, we have that interface which is 192.168.10.65. which falls under this network ID of 192.168.10.64. This is the interface that we're currently talking about, which is a loopback 0. Okay, now all we have to do again, we need to ensure that this is advertised on the dynamic routing protocol RIP by typing the command network 192.168.10.64. right. I already specified the command not auto summary, so I can just go back to the global config mode, and then I have to, while I'm still here on this RIP configuration, I can actually advertise the other network, which is 192.168.10.96 by typing the command network 192.168.10.96. Okay, now I can exit. I've advertised two of these loopback interfaces. All I have to do now, I have to do a ping to a Google DNS, but from a specific source. Okay, do ping 888 from this interface of loopback 0. Okay, the first one is dropped, but let's try the second one. As you can see, we have actually managed to send the packet through to the internet. Okay, so we sent and then we received. So let's see what happens if we ping from loopback 0. So we need to ping. We already tried to ping on loopback 0. Now let's see if we can ping from loopback 1. This is L1, which stands for loopback. Let me just type it in full. Loopback 1. Okay. As you can see, we can also ping from that loopback interface, which is located on this domain. So we have that 192.168.10.97 as our IP address that is configured on this loopback 1. So when we ping from this specific source on that router over there, which is R5, we can actually go to the internet. Okay.